the next portion, we're going to go ahead and look at operations with signed numbers. We're going to start by looking at combining signed numbers using addition, coming from section 1.5. In order to do this, we want to know how to add and subtract whole numbers, and how to add and subtract like and unlike fractions. Upon completing this presentation, you will be able to combine signed numbers that are written as an addition problem and know the four properties of addition. Before we discuss the basic idea of adding integers, we're going to look at some examples that will provide you some context to help you remember the rules. The first one that we're going to look at is adding integers with a number line. In order to do this, you want to start by plotting the first number on the number line using an open circle. Then, using this as your starting point, you want to move the number of spaces indicated by the second number. You're going to move to the right if it is positive, and to the left if it is negative. The number where you land is the result. You want to identify it in reference to 0. So let's look at some examples and see what we come up with. First example, we have 5 plus 3. Now, I'm pretty sure we all know what the answer is, but let's go ahead and kind of see this as our base case. If we plot 5, we end up to the right of the origin 5 units. From there, I want to move 3 to the right. So we're going to go 1, 2, 3. We end up at 8 from the origin. So now let's go ahead and see what happens when we start getting negatives involved. Starting with -3 plus -4. -3 is 3 to the left of the origin. I'm going to label that with an open circle. And now I want to move 4 units to the left. If we move 4 units to the left of -3, we end up at -7. So -3 plus -4 equals -7. Let's look at C, -1 plus -3. -1 is 1 to the left of the origin. If I move 3 spaces to the left, where do we end up? We end up at -4. So -1 plus -3 equals -4. Let's look at a couple more. 3 plus -5. 3 is to the right of the origin. If I move -5, I want to move 5 spaces to the left, and I end up at -2. For the next one, we have -6 is 6 to the left of the origin. And now if I want to move +2, I want to move 2 to the right. Leaving me at -4. If we look at F, we have -2, which is 2 to the left of the origin. And if I move 4 spaces in the positive direction, I end up at +2. And finally, the last example, we have positive 2, which is 2 to the right of the origin. And if I move 7 spaces to the left, we end up at negative 5. So this is the first example that you can look at. Now, granted, when we start talking about adding 2 and 3-digit numbers, adding using a number line is probably not going to be the way that we want to do this. But it does help us think mentally of where we're going and what we get at. We'll bring these results together later when we talk about our rules for adding signed numbers. All right, the next example we're going to look at is adding integers with manipulatives. I recommend using either poker chips or 2 different colored objects to help with this. I'm going to use blue chips and red chips to represent my numbers. Blue chips are going to represent my positive numbers, and red chips are going to represent my negative numbers. So the first thing that we want to do in order to add is we're just going to lay out however many blue chips for our positive number and how many red chips for our negative number. From there, we want to pair up and remove any chips that are different colors. And finally, the number of chips and the color that they are is going to equal your answer. All right, so let's go ahead and look at some examples. Example A, we have 1 plus 5. All right, so this is pretty straightforward. We're not really doing anything with signed numbers here. You all should know that 1 plus 5 is equal to 6. But if we look at this visually, what do we have here? We have 1 blue chip and 5 blue chips. We have 6 blue chips, and so our final answer is going to be positive 6. All right, let's do another example, and let's go the other direction. Okay, what if we are adding 2 negative numbers? Here we have negative 3 plus negative 4. Visually, what we're going to do is represent this using 3 red chips, and we want to combine it with 4 red chips, which is equal to 7 red chips. So mathematically, this is equal to negative 7. All right, so those two are pretty straightforward. Now we're going to go ahead and get into some examples where we talk about combining positives and negatives. Let's come down to example C. We have negative 2 plus 6, which means that I want to combine 2 red chips with 6 blue chips. And this is where we need to start doing our cancellations. We're going to pair up any pairs that have different colors, and we're going to cancel them out. So for instance, here we have a red and a blue, cancel out, and we can actually do this twice. So that's what we're going to do. I'm going to go ahead and mark them out as black, just to show that these have canceled out. And what do we have left over? We have 4 blue chips, which means that our final answer is going to be positive 4. All right, a couple more examples. Let's come over to example D. And the first thing that I need to do is I need to go ahead and add another blue chip because I can't count. So for 7 plus negative 4, we have 7 is positive, so that's going to be 7 blue chips. We have the negative 4, 4 is negative, which means 4 red chips. And we want to combine this. And so same thing, we're going to go ahead and cancel out pairs that are different colors. And we have 4 pairs here that are different colors. And so we're going to go ahead and cancel them out. And we are left with 3 blue chips, which means that 7 plus negative 4 is equal to 3. All right, two more. Example E, we have negative 7 plus 1. So we have 7 red chips, 1 blue chip. We cancel out the ones that have different colors. And that leaves us with 6 red chips, and so our final answer is going to be negative 6. All right, for example F, our last one, we have 5 plus negative 7. And so we have 5 blue chips and 7 red chips. If we go ahead and pair off our different color chips, we can cancel out these two, these two, these two, these two, and finally these two. And so this is equal to negative 2, since we have 2 red chips left. All right, that is this particular way of thinking about adding and subtracting, or adding sign numbers. Let's look at a couple more examples. Our final analogy that we're going to look at is in terms of money. And for many of us, this is the most practical way to think about adding sign numbers. This is stuff that we do every day. And so if this is the analogy that helps you remember your rules of adding sign numbers, then you may want to just slap some dollar signs in front of your numbers so that you have a context. So when we talk about real life applications and working on these with money, notice that we have 2 things that we're going to have. We have having money in the bank account, and deposits represent positive numbers. Negative numbers are going to be represented by being overdrawn and writing checks. So let's look at some examples. The first thing we want to do is translate this into a mathematical statement and then determine what is going to be our answer. So we have $20 in our bank account. That is going to be a positive number. And we deposit 12 is also a positive number. And so what is going to be our new balance? Our new balance is going to be $32. Let's look at the second example. You have $15 in your bank account. That is a positive number. Now, if I write a check for 11, that's going to be negative. For now, I'm going to write this as an addition problem. I'm not going to write anything as subtraction. So we have 15 plus negative 11. And so what would be the new balance? Well, if you had 15 and you basically got rid of 11, that would leave you with a total of $4. For example C, we are overdrawn 11. Remember that overdrawn means that we don't have the money. We're actually in the negative. And we want to deposit 23. So of those $23, we need to devote 11 of those to taking care of our overdraft. And then what are we going to be left with? We should be left with a total of 12. It will be positive, and so that is our final answer for that one. Now, for D, it says that we are overdrawn 16. We deposit 9, so 16 will be negative, and 9 will be positive. So if we're overdrawn 16 and we deposit 9, well, $9 will take care of part of our overdrawn balance. But we are still overdrawn $7. For example E, we are overdrawn $2, and we write a check for 13. So both of these numbers are negative. Well, if we're overdrawn $2 and we write a check for 13, we're going to be overdrawn more. We should be overdrawn a total of $15 now. Finally, our last example, we have $14 in the bank account. We write a check for 25. So of that $25 check, 14 of it is going to kind of cancel out the amount that we already have in the bank account. The rest of it is going to be overdrawn still. So we should get a total of negative $11. So that takes care of our money applications. So now that we've finished looking at our 3 analogies, let's go ahead and talk about the rules for adding signed. When we talk about adding signed numbers, we have 2 different categories to consider. Either they have same signs, or they have different signs. Each one of these has a different procedure. So if we have numbers with same signs, the rule is we want to go ahead and add the numbers, disregarding the signs. That means we're going to add their absolute values. And we want to keep the sign. So if we're adding 2 positive numbers, our result is going to be positive. And if we're adding 2 negative numbers, our result will be negative. Our second category that we need to consider is if they have different signs. If they have different signs, we're going to subtract the numbers, disregarding the signs. And we're going to keep the sign of the larger number. If you go back and look at the examples that we've already done, you will see that this is exactly the operations that we want to consider. So let's go ahead and look at some examples and talk about what we need to do or what we need to be thinking about as we do these. If we look at example A, we have negative 11 plus negative 15. The first thing that I want to note is we do have same signs. We have a negative 11 and a negative 15. Remember that if they have same signs, we want to add, disregarding the signs. So 11 plus 15 is 26, and we want to keep the sign. So our final answer will be negative 26. Looking at example B, we have negative 13 plus 4. For this one, note that we have different signs. So recall, if they are different, we want to subtract. 13 minus 4 is 9. And we want to keep the sign of the larger number. Since our larger number is negative, my final answer will be negative. Let's look at example C. Example C, we have negative 17 plus 23. Again, we have different signs. I want to subtract my values. Note that whenever you do your subtraction, you always have to do larger minus smaller, irregardless of where they are in the problem. So when I look at this, I can't do 17 minus 23. I have to do 23 minus 17. We get 6. We want to keep the larger sign. Since my larger number is positive, my final answer will be positive. For example D, we have 4 plus 18. Now I know that we all want to sit there and say what the answer is because this is a very basic problem, but let's go ahead and review what it means to add in terms of them being sign numbers. Note here we have same signs. They are both positive. Remember that if they are same signs, we want to add. 4 plus 18 is 22. And we want to keep the sign. Since both of these numbers are positive, our final answer will be positive. And for the next example, or the last example in this column, we have 5 plus negative 12. We do have a positive 5 and a negative 12, so that means that we have different signs. If we have different signs, we want to subtract. Again, larger minus smaller. 12 minus 5 is 7. And we keep the larger sign. Since my larger number is negative, my final answer will be negative. Let's look at one more example involving integers before we move into fractions. We have 8 plus negative 6. Since we have different signs, we want to subtract. Again, I'm going to do larger minus smaller. 8 minus 6 is 2. And we want to keep the larger sign. Since my larger number is positive, my answer will be positive. Now let's look at some examples containing fractions. So not only do we need to remember our rules of signs, but we also need to remember how to add fractions. So remember that we want to have a least common denominator. We'll start with that. If we look at example G, our LCD is 20. 20 is divisible by 4, and it is divisible by 10. So for the first fraction, we need to multiply by 5, giving us 15 over 20. Remember to keep the negative, plus our second fraction we want to multiply by 2, giving us 2 over 20. Recall that from here we want to combine the numerators together. If we combine the numerators, we have different signs. So we want to subtract, giving us negative 13 over 20. Remember to keep the sign of the larger number. Let's look at our next example, H. Again, the first thing that I want to do is figure out the LCD. For this one, my LCD is 6. 6 is divisible by 3. It's also divisible by 6. So my first fraction, I need to multiply by 2, giving me 4 over 6. I keep my negative, plus negative 1 over 6. From here, we have same signs. So we want to add and keep the sign. We're just going to work with the numerators, so we get negative 4 plus negative 1 is negative 5 over, we keep the denominator, we get 6. For our last example, we want an LCD. So what is a number that is divisible by 5 and 7? We should get 35. So my first fraction, in order to get from 5 to 35, I want to multiply the bottom by 7, and whatever I do to the bottom, I do to the top. This will give me 21 over 35. For the second fraction, to get from 5 to 35, I need to multiply by 5. And again, whatever I do to the bottom, I need to do to the top. So I get minus 20 over 35. From here we have different signs. So I want to subtract. 21 minus 20 is 1. We keep the sign of the larger number, which is positive in this case, and so we get 1 over 35. So there are some basic examples of how to add signed numbers. If we go ahead and apply what we know to an application problem, we can go ahead and start by writing a mathematical model. Mathematical model means just write it as using adding and subtracting, or addition in this case, and then we'll go ahead and solve it. So the first thing that we have here is we have a glider was towed 1,000 meters into the air. This is going to be positive. From there it descended 70. That will be a negative, into a thermal rising bubble of warm air, which took it up 2,100 meters. At this point it dropped 230 meters into a second thermal, and then it rose 1,200. So the numbers here underlined in green are going to represent positive numbers, and the numbers underlined in red are going to be represented by negative numbers. Again, for this problem, I want to go ahead and just use addition. We're not going to use any kind of subtraction symbols. So we have 1,000 plus negative 70 plus 2,100 plus negative 230 plus 1,200. From here, we want to go ahead and combine our numbers. Now, this round, I'm going to go ahead and work from left to right. So starting on the left, we have 1,000 minus 70. This is going to equal 930. From there, I want to add 2,100, and we get 3,030. I can subtract 230, and we get 2,800. And then I can add 1,200 to give me 4,000. So my new altitude is 4,000 meters. Make sure that whenever you do application problems that you have some kind of interpretation, which is the sentence, and that you also have include correct units. So that brings us to the properties of addition. The first property that we have is additive identity. Identity in mathematics in general means that it does nothing. You keep the same number that you started with. So the additive identity in addition is 0. Anything plus 0 is itself. The other concept that we have related to identity is the concept of an inverse. Two additive inverses, or two inverses, will combine to the identity. Since we're talking addition, that means that we want numbers that will combine to give us 0. So when we talk about additive identity, what we're talking about is the opposite of a number. 5 plus negative 5 is 0. Negative 7 plus 7 is 0. So you have that any number plus its opposite is going to result in 0. Finally, the next two operations that we have to do with how can we add numbers. The first one that we have is the commutative property. When you hear the word commute, you should be thinking about, for instance, commuting to work. In the morning, I leave home, I drive to work, and at the end of the day, I drive from work back to home. And the distance should be the same. Well, when we talk about the commutative property, it's basically the same thing in mathematics. Changing the order does not change the result. A plus B is equal to B plus A. Hopefully, if you are a finger counter, you take advantage of this operation, or this property. For instance, if I want to know what is 2 plus 83, I'm sincerely hoping that you do not start with 2 and start adding 83 onto it. You should be able to start with 83 and just go 84, 85. The last property that we have for addition is the associative property. The associative property, if you think about if you have kids or if you remember when you were in high school, your parents probably wanted you to associate yourself with the band geeks, the smart kids, the cool crowd, the cheerleaders, the football team, whatever group you want. Associative property, that's exactly what it means, is we are talking about grouping. And what it means is the grouping does not matter. So for instance, I can start by adding B plus C and then adding it onto A, or I can start by adding A plus B and then adding C onto it. The main thing to keep in mind here is that with addition, we have a lot of freedom. You can add these numbers in any order, you can add them in any grouping. So let's go back to our application problem. What we can do is we had our original model of 1000 plus negative 70 plus 2100 plus negative 230 plus 1200. What we can do here is, instead of starting at the left and going to the right, I can start by combining my positive numbers. If I combine my positive numbers, I should get 4,300. I can also combine my negative numbers. Negative 70 and negative 230, since they have same signs, I want to add them and keep the sign. We get negative 300. And now if I go ahead and combine my final two numbers, we have different signs. So I'm going to subtract, keep the sign of the larger number, and include my correct units. So either way, you should still get the same answer. So when will we see this again? Adding signed numbers is going to show up throughout the course. We will be constantly working with signed numbers. We will expand the concept when we talk about simplifying expressions involving variables, as well as solving equations. We will also expand the concept when we talk about polynomials and negative exponents, And we're going to need to be able to think backwards when we get to factoring polynomials. Take a few minutes now and try the following problems on your own. Bring any questions you have as well as your solutions to the next class.